Supernova 1987A is the nearest supernova explosion that we've observed to Earth since we've had modern telescopes. We don't always know when we see a supernova in a galaxy what the star was beforehand. We have to be lucky. And one of the nice things about Supernova 1987A is it's in the Large Magellanic Cloud, which is the nearest sizable neighbor galaxy to the Milky Way, close enough that a lot of study had been made before the explosion of the stars in the galaxy for all sorts of other reasons. And so once it exploded, we could go back and look at that other work and say, oh, it was a blue supergiant, most likely before it exploded. It was a star about 19, 20 times the mass of our sun. And it went through its normal hydrogen burning phase and fusion phase. It puffed up, turned into red supergiant, which is cool and has a slow-moving wind coming out, expelling a lot of material, blowing off the star. And then it evolved into something called a blue supergiant, which is a bit hotter and has a faster wind. And so the faster wind caught up with the slow wind and made a ring of dense material. And so there was this ring of dense material there, and then the star continued to evolve, and then it exploded. And it took about 15 years, but the blast wave went out and started ramming into this knotty ring and lighting that up now. And then into everything, basically everything interior to that blast wave that came off the star was material that used to be in the stellar core. We looked with ALMA at Supernova 1987A, and we discovered that inside, in the part of the object that used to be deep inside of the star before it exploded, that material, sort of pristine material, if you will, a lot of that has gone from the temperature of the inside of a star, so millions of degrees, has cooled off a whole lot and is now condensing. Some of the gas is condensing into dust grains, and so it's made a whole lot of dust. When a massive star explodes, it's possible that it completely disrupts what's left, but it almost certainly made a neutron star or a black hole. But we haven't found either of those things yet. We've been searching at every wavelength in every technique, and so we would very much like to know what the remnant is that's left behind. It's possible that ALMA will be able to address this. It's rare in astronomy that we have a laboratory. We can't make stars explode when and where we want to, and so to have an object where we know pretty well how it started and how the explosion began and what the initial conditions are, and then watch all this other physics unfold on a human time scale instead of a million years is very exciting for a lot of reasons.